Let's start in. We did number 1 yesterday. You guys had your answer there. Let's finish up this. Let's go on number 2. So it's really helpful to maybe use a separate sheet of paper. How many have an answer for 2, just so I know who I'm talking to here? Okay. What did you guys get?
No solution.
Okay, no solution. That's very true. So no solution, just so that we're aware when we go through it. First thing I do is I'm looking at this and I'm going, hey, this right here, this, and this, and this. Okay, I can't take anything out of those. This right here, this, and this. I can't take anything out of those, so I can't reduce that. And obviously on the top, since there are already ones, I can't. Okay, so if you can't reduce it, from there, maybe trying to combine 2 equations. So which ones did you combine to make it so that you didn't, or you tried to eliminate something? 2a and b. Okay, so by doing that, you're eliminating x. Okay, so if I go 2a is 2x minus 2y plus 6z equals 38. It's really hard to see that a. So. And then add that to b. Negative 2x plus 2y minus 6z equals 9. Yeah, it looks like everything eliminates, right? We get 0 equals, unfortunately, not 0. Or maybe fortunately. Some of you are like, all right, woohoo, that is fortunate. No solution. Okay, because 0 never equals 47. Okay. Yeah. Emily. 1/2 b. Oh, sure, yeah. If you cut this in half, it just means you get a fraction here. But that's fine. Yep. 1/2 b plus a would work also. Okay, well, let's go on to 3. How many got 3? Who has an answer for 3? Okay, who got stuck on 3? You got part of the way and you're like, okay, I'm done. I just don't know where else to go. Hey, I haven't brought this up this year yet, but my expectation as a teacher is that you are not spending any more than about a half hour a night on math. Okay? So seriously, if you get to a point where you're spending way too much time on math, then you need to stop and send me a message, and we can try to figure out what's going on the next day. But the assignments are not meant to be that long. So if you spend more than a half hour on this last night, I don't want you freaking out. And plus, I forgot to post the video until like 9 or 8:30. So I don't know when it was, but whatever. Just so you know, you made it further than my other class yesterday, though. So let's those of you who did this one, how'd you start out?
2a and b.
Okay, hold on. What was that? 2a plus b. Okay, did anyone else do 2a plus b? Okay, now you don't have to go that route, but let's try it that way. If I go 2a plus b, 2a is going to give me, well, I should check it, see if I can reduce first, and I can't reduce any of them. So 2x plus 2y minus 2z equals negative 18. And I add to it b. That is going to be 2x minus 3y plus 2z equals 13. So your plan was to eliminate z by doing that? Okay. So it gives me 4x minus y equals, and that is an x, equals negative 5. All right, and we're going to call that equation D. All right. Now I need to eliminate z from equation C. So what equation do we want to use for that? Matt? Okay, so 3b plus c. So if we go 3b plus c, that will eliminate that. Good. So 3b is going to be 6x minus 9y plus 6z equals 39. And c, still 3x minus 5y minus 6z equals negative 15. Okay, put them together. 9x minus 14y, 0 there, equals 24. Good? Call that equation E. Hope you guys are checking my work as we go. All right. So now I need to use D and E. So equation D and E to eliminate a third variable. So just so we know, we're using those two. We're eliminating a second variable, excuse me. Which variable? Who says Y? Who says X? Okay, we're going Y. We went straight majority there. And to do that, it made it easy. We only have to multiply one of the equations by something. So which one are we going to multiply? D. We're going to go, how many D's?
Negative 14.
Negative 14 D's plus E. Okay, negative 14D is going to give us some values, for sure. Negative 14 times 4, 56. Negative 56, X. Negative 4, or positive 14Y. And positive 70. And then we have E. We get 3X. Whoops. Not 3x, 9x, looking at the wrong equation, minus 14y equals 24. Okay? Combine, gone, negative 45x, no, negative 47x, thank you, equals, man, 94. Isn't that convenient? X equals negative 2. Phew. All right, let me pause there. Now, how many of you made it that far? How many got stuck right there? Okay, how many got stuck prior to this? How many made it farther than this? Okay, so once you get to D and E, you're eliminating a second variable. And then from that second variable, okay, quiet please. From that point, once you've eliminated that second variable, you know one of your variables. And from this point on, you're working your way backwards. So if I know x equals negative 2, I could plug negative 2 back into either D or E. It looks more appealing in D. So if I use equation D and plug negative 2 in, I could say that's 4 times negative 2 minus y equals negative 5, or negative 8 minus y equals negative 5, which negative y equals 3, so y equals negative 3. Okay, how many got negative 3 for y there? Good. And then once I know x and y, I can use that in one of my original 3 equations. Okay, and solve for z. So yeah, it might be easier in A. So I know x is negative 2. Plug that in for A. Y is negative 3. Minus z equals negative 9. That's negative 5 minus z equals negative 9. Add 5 to both sides. Negative z equals negative 4. So z is 4. Kind of worked upwards there. All right, so we get the order triple. Negative 2, negative 3, 4. All right. Okay, how many of you got it? How many of you know where you made your mistake? Okay, that's the goal, is to know where we made our mistake and get stuck. How many of you are still stuck? Okay, well, and if you still get stuck, then you can talk to me about it in a while, and I'll look at your work. Okay. Very good. Last one, number 4. Taking a look at number 4. You guys, part of this is my fault, because I asked you to do number 4, but I forgot to tell you could just get rid of substitute. You don't have to use the substitution. Just solve it. Okay? Oh, man. So, just so you're aware, when they say use the substitution method, I look at this says x plus y, and this has x plus y. You guys see that? So, if I move this z over here, if I move that z over there, that if you're wanting to use substitution, Kind of nice sometimes, but if I move z over there on that one, letter B would give me x plus y equals 4 plus z. Everyone see that? And then I could take this piece, because x plus y equals that. I could take and plug that in for x plus y right there. It's pretty easy, right? Because you got z right away. Okay? When I do that, if I plug that in for a using substitution, there's no longer where we had our x plus y plus z equals 4. This part gets plugged in right there. So I now have 4 plus z equals 4. Right? 2z equals 0, or z equals 0. Cool? No. Okay. Do you understand where the substitution came from?
Yeah.
Okay. So all we have is one variable right now, though. Can you see anywhere else you could do that? Y plus z what? Y plus z equals 4 minus x. So right here. Anyone else see what we're talking about there? Okay. You guys, I'm not going to go through substitution because I think it's a bit more advanced right there, but I kind of touched on it. What I'd like to do, though, and I'm not saying you're not advanced, I just know when you're learning something like this, it makes it tough to grasp multiple things at once. So where we see that, we may use it every once in a while, but I want to try to approach this problem like most of you would have approached it using elimination. So looking at this, if I just ignore those parentheses there, but if I look at this, what could I eliminate? I could eliminate z, right? I could go a plus b, and I know a plus b in this case gives me 2x, 2y, 0 for z, and 8. And I can even reduce that, right? Divide it by 2, that gives me x, y, and 4. All right, we'll call that equation D. And now if I eliminate z and c, I could either use, well, probably use b would be best, right? B plus c. And in that case, I get 4x, 4y, 0, and 16. And once again, I can reduce it. That becomes x, y, and 4. Now, those two are exactly the same. Okay? We know that x plus y equals 4 and x plus y equals 4, or using substitution again, we have 4 equals 4, which means infinitely many solutions. Now, for those of you who are like, hold on, didn't z equal 0? Yeah, z equals 0. However, x and y, you can't get solutions for. You're getting, the variables are canceling. So you get 4 equals 4. That's infinitely many. If it was 4 equals 8, that would be no solution. Okay. How many got infinitely many there? All right. How many of you got stuck with the substitution thing? You're like, well, he didn't even teach us that. What kind of teacher is this? Okay. All right. Okay. Questions? All right. Well, your assignment today, let me get that for you because I love every minute of it. Hold on. Okay. Your assignment, I will put it up here so you can look at the amazingness of it. There are a total of 9 problems. Anywhere where it says use substitution, you can solve these any way you want. Okay? All right. Now I will tell you the ones where it says use substitution on this assignment on the back, those are a lot easier to use substitution on. Like number 7, you should be looking at thinking, oh, yeah, that's easy. Okay? I hope. If not, then I don't know. Then we really need to talk about it. All right. So let me get that out to you guys. To maybe help us out a bit, I would like to try to, as a class, work through number 6. We haven't done a story problem yet, but the first thing you need to do as you're going through this, make sure you go through and write out your equation. Now, if there's one equation or one variable, you need at least one equation to solve. There's 2 variables, you need 2 equations. If there are 3 variables, you'll need 3 equations. If there are 4 variables, you need 4 equations. Okay? So, as you're working through this, if you're like, dude, this has 20 variables, you better write down 20 equations. Okay? All right. Go ahead and try to work together with your groupies. Work on number 6 to begin with. Try to get those equations. Okay, so 3 bouquets of flowers are ordered at a florist. 3 roses, 2 carnations, and a tulip costs 14. 6 roses, 2 carnations, 6 tulips costs 38. 1 rose, 12 carnations, and 1 tulip costs 18. How much does each item cost? So what are our variables here?
T, R, and C.
Okay, so we're saying roses, number of carnations, and number of tulips. All right, so we're using those 3 variables. I'm going to... All right. We're talking about the number of each of those. Okay, so first equation.
3R plus 2C plus 1T equals 14.
Good, so 3R there, 2C, and 1T, or just T. Okay? Maybe I should make that a lowercase t now. Equals 14. Another equation. Okay, pause, please. Hey, how many are done with this? Okay, almost. What's the other equation? Stas, what'd you get? Good. 6R plus 2C plus 6T equals 38. And the third equation? Yes, Sammy? All right. And then Walsh said that we could reduce the middle one, right?
Yep.
So that actually could become 3R. They were taken out of 2. And 1C. And 3T. And 19. Okay, so if it's helpful, it'd probably be nice to look at that in a nicer format. Okay, so from there, once you actually take out the equations, then you can go through and solve. I'm not going to solve that one for you, but at least that's how you can get the equations out and then reduce them. So, I'll let you guys go from there.